Okay, so we talked about divergent series. We're going to talk about another divergent series, which is called the harmonic series. This one's a little more interesting, okay? And the reason is well, let me write it down. The harmonic series is the sum n equals 1 to infinity, 1 over n. This is 1 plus 1 half plus 1/3, so on and so forth. And this actually also diverges. But the reason it's interesting is that each term still goes to 0. So even though each term goes to 0, it still might diverge. Okay, so, right, yeah, makes the things a little bit harder, but interesting. Okay, let's first talk about why this diverges. Okay, what we're going to do, we're going to form sort of subsequences. Okay, so let's write S sub n equals, let me write this, yes. Changing the index. Okay, so k is going to go from 1 to n of 1 over k. All right, so S sub 1, 1, no problem. S sub 2, 1 plus 1 half. No problem whatsoever. Everything's good. Now let's go, we're going to do powers of 2. Okay, so we're going to skip S3. I mean, it's still there, but we're just going to look at S sub 4. S sub 4 is 1 plus 1 half plus, and I'm going to group these together, 1/3 plus 1/4. Now, here, 1/3 is definitely bigger than 1/4, right? 3 is less than 4, so 1/3 is bigger than 1/4. And I have two of these terms. Okay, so what I have here is that S sub 4 is actually bigger than, okay, 1 plus 2 halves. This is bigger than 1 half. 1/4 and 1/3 is bigger than 2/4. Okay, let's go to S sub 8. All right, S sub 8 equals 1 plus 1 half. We're good. Let's group these again together. 1/3 plus 1/4 plus, now we're going to group the other terms together. Let me write them down. Okay, here, 1 plus 1 half. Good. We already got that this is bigger than 1 half, right? Now, here, we've got how many terms? 1, 2, 3, 4, and all of them are bigger than 1/8, except for the 1/8. So all of them are bigger than or equal to 1/8. So this is bigger than 1 plus 1 half plus, this is the 1 half that comes from here. And then here, this is bigger than 4/8, which is 1 half. Ah. Okay, let's do S sub 16, which actually 16 is 2 to the 4th. So let me do that one. 8 is 2 to the 3rd, right? This was 2 squared. So this is 1 plus 1 half plus 1/3 plus 1/4 plus, I'm not going to write all these down, plus 1/9 plus 1/10, I'm not going to write these all down either, all the way to 1/16. Now, easy to get a little confused here. How many terms are here? That's right, there's 8 of them. Okay, I know it seems weird because 16 minus 9 is 7, but we have to also include the endpoint. Let me write that 9 a little better. Okay, just like here, 4 minus 3 is 1, but there were 2 terms. 8 minus 5 is 3, but there were 4 terms. 16 minus 9 is 7, so there are 8 terms, all bigger than 1 over 16. 1, 1/2, 1/2, 1/2, 1/2. So this is bigger than 1 plus 4/2. So what do we get? We get that s sub 2 to the n should be bigger than 1 plus n over 2. And what's going to happen to this as n goes to infinity? Okay. Now, granted, this is going to go pretty slowly to infinity, but it's still going to go to infinity. Okay? In fact, it's going to go to infinity kind of like how the integral of 1 over x goes to infinity. Remember, that's log of x. Okay. The sum and the integral is related. We'll talk about that later. That's an integral test. Okay. But while we're here, we may as well just, I'll give you guys the P series. We'll talk about it some more later. But in general, just like the P integrals, okay, this is going to converge if P is greater than, not greater than or equal to greater than 1, and diverge if P is less than or equal to 1. Okay, so here, this is the P equals 1 case is divergent. Okay. All right, I think that'll do it for this video. I'll see you in the next one.